Thank you. Yeah, so that intro was like completely wrong because it's Shopify, and we kind of hate the word microservice, even though we kind of sort of do it. Like we use the word like microservice or multilith more. But anyway, so I'm going to be talking to you about so we had this problem of how do we get better sort of operational infrastructure around all of our different apps that we're running. And we weren't doing a very good job of this, so we started a project to like more systematically track this. So I'm going to tell you a little bit about this project that we did, go through some of the motivations, some of the results, and hopefully extract a few lessons learned that you'll be able to apply in your own companies. So just to set the bar a little bit, because you probably don't know the company that well, I just want to give you an idea of what I mean by scale, because if you're like Google or Facebook or huge companies, you might have a totally different idea of scale. So we'll just talk a bit about like what scaling concerns that we were facing here. So if I rewind just about 4 years ago, Shopify was a small, privately held company building software for commerce, for retail. So we basically provide all the software you need to run a store. And we were in a state of very rapid growth. So we'd gone from 30 developers to about 115 over 2 years. And our rate of release, so we'd been releasing changes to production about 3 times a day, and we'd double that every year to be deploying about 12 times a day. And that was just 2 sample metrics. Like across the board, everything was growing very, very, very quickly. So fast forward a couple more years, and this growth rate continued. And things were starting to not be okay with it. So the growth was kind of getting ahead of us a little bit. I actually wasn't at Shopify at the time, but I've heard many legends about those days, like Redis-mageddon and these DDoS attacks and flash sales and all kinds of exciting things were going on. And it was clear that we weren't staying keeping ahead of the growth. So it was at that time that we adopted our production engineering or SRE model. And it was extremely timely that we did that because the next 2 years looked like that. So growth continued at a kind of ridiculous pace. Everything's doubling, but having the SRE model, the production model, definitely helped us stay ahead of that. But the main thing that concerns us, the main thing we are preoccupied with is not actually the size, it's the growth rate. So we're always trying to predict not just linear, like if things go as they are, what do we need to have in place? It's like what happens if things double in a couple months, then what do we do? So trying to stay ahead of that growth rate is the thing that keeps us awake at night, I guess.
Could you allude to some of the numbers, because it's almost impossible to read?
Okay. Yeah, the numbers aren't. Oh, yeah, it's not very great with this lighting, is it? So this is the number of developers we have in the company. So right now we have just about under 900 developers. So we'd gone from about 30 developers to 900, and we'd gone daily deployments to production, about 3 deployments in 2011, up to currently we do about 250 or so deployments to production of different services. So it's the rate of change is going up, and the number of people involved is going up very fast. The numbers actually aren't that interesting. It's more the shape that's kind of scary. So here's maybe a nicer way to visualize it. So this is an image of a Shopify developer who joined the company about 4 years ago. They got on this rickety little wooden cart with 2 wheels. Maybe it was being pulled by a mule. Then 4 years later, they look up and they're like, holy shit, where do these horses come from? And it's got wings, and I'm flying through the air. So it was like, that's kind of a feeling of what it's like. It's like we started off at this rate, and then when we look up, we're like flying through the air, and it's really, really quite crazy. So that's just a little bit about the scaling kind of things we're concerned about. Now I just want to talk a little bit about what I mean by service infrastructure. So you tend to think of, if you think of software like a race car, the outside view might be that it's the race car that wins races, right? Or maybe the hotshot app developer is the driver. And it's kind of the car and the driver are the things that win races. But it's actually, there's this huge sort of context around the race car or around our software that enables us to deliver. And that's what I mean by service infrastructure. So it's basically all the things that are around the actual app tier that keeps it running. So some of the concerns I'm talking about here are things like all the infrastructure you need in place for development. So having a local automation of your local development environment set up, CI pipeline, deployment automation, all the tools you need to be able to track and instrument your system in production. Telemetry of information about the running service, automatic tracking of bugs, retention of logs, and that kind of thing. So there's all these different kinds of concerns that we have about all of our different apps. But then when you multiply this across a large number of services, it gets very scary. So again, the numbers, so we had about 10 production systems about 6 years ago, and today we have about 250 or so systems in production. And we are growing a new production service about once a week on average. So it's a very high growth rate. And when you think about that huge list of things you need to get in place across that many services, it becomes quite a nightmare to get in place. So, and we notice this anti-pattern emerging that I'll call spreadsheet-defined infrastructure. So we'd have, let's say there's some change that needs to be made across all systems or a category of systems. How do you even figure out what systems are affected and how do you get it done? So this is actually a real example of, this one is called Apps Soon to be Using Unsupported Rails Version. So these are Rails apps that are about to be, the next zero-day security exploit that comes along on Rails. These apps are going to be in big trouble. And we're trying to gather all the context around, like, where's the source code? Where is it running? Like, who works on it? Is it important? Can we just shut it down instead of upgrading it? So there's all this context you need to build up in order to make these kinds of infrastructure changes. And we found we had to kind of do this over and over again every time we needed to make one of these kind of changes or decisions across a fleet of services. So now we get to the actual details of the project. So how do we do a better job of tracking these services? So we had three main goals for this project. So the first one, which might seem odd for depending on what your company is like, defining ownership. So we actually didn't have concrete owners of software at Shopify. It was a very collective kind of ownership model. So we wanted to define owners. We wanted to be able to measure like how well are we doing and are we getting better or worse. And then most importantly, we wanted to use this as a platform for building out automation so we can make it easier to get better. So the first goal of ownership. So Shopify has one of its corporate sort of mottos or values is act like an owner. So the company actually has very little corporate structure or corporate rules or anything like that. There's this one overriding rule that is when you have to make a decision, if you were the owner of the company that you were 100% invested in the future of the company, what would you do? Okay, do that. So that's kind of like this overriding rule of like how to govern your behavior at Shopify. But that doesn't work so well in, if you have 900 developers, all of whom are asked, act like an owner, jump in and fix things, it kind of becomes this bystander effect, right? Where everyone is well-intentioned and would jump in if they thought it was the most important thing, but they're not sure maybe someone else will do it. So a couple of examples where having a clear owner is really valuable. One is like when there's an incident going on, right? So something's down, like, does that matter? Like maybe it doesn't. Maybe it's this crappy old service that no one cares about. Who knows enough about it to help us fix it? So that's the situation where you very quickly need to define an owner. Another example is when you want to make like long-term decisions about a system. So you want to add a new feature. Should I add it to this thing, or is this going to be end of life? And should I move it somewhere else instead? So you need to have someone who has sort of a stake in that system or that service to be able to help make these kind of decisions. So we really thought about this carefully because there's a lot of, if you think of ownership of software as a spectrum where you have this collective ownership on the far left, like the startup world of everyone just jumps in and does whatever they need to get done. And then at the far end, that way for you, like the authoritarian kind of model that you tend to see in large organizations where it's like very strictly defined who can touch this thing, and you probably can't even see the source code for it if you're not on that team, that kind of thing. So we wanted to retain the value of collective ownership as much as we could, but have a little bit more structure behind it. So the approach we took there was actually, really just did the simplest thing we could think of. We have this metadata file in every GitHub repo that has information about a service. We actually added owner in there. So you record in there either an individual or a team, depending on the importance of the service. And the really neat thing about having it in the GitHub repo with everything else is If ownership needs to change, you just open a pull request, you get it reviewed, you get in the stakeholders who care about this, have a discussion, figure out what the right answer is, and ship it. And then you have this sort of history of like how was that decision made and who was involved and like what was the outcome and why. So it's really super simple model, but it worked really well for us, and we've done that across all of our production systems. Now have this piece of metadata in there that says what team or individuals own it. So our second goal of doing better at measurement. So are we getting better for worse or worse? Or if I'm responsible for a large number of systems, where do I spend my time? Where's the most appropriate place to spend my time across all these things? And also, like, what's the right amount of work, right? Like, there was a talk earlier from I think it was someone from Netflix was talking about I want all the nines, but of course you can't have all the nines, right? You have to decide how much work am I going to put into this. So we wanted to give development teams a guide to help them make that decision of what's the right amount. So the first thing we did was we sort of reached out to all the different systems, like all this infrastructure. So here, I have here like Splunk, Bugsnag, PagerDuty, playbooks. I have like the Git repo. Basically all the different systems that are involved with the life cycle of a piece of software. Connect out to all those and correlate them with a service. And the very first useful outcome is it enabled us to create these nice little dashboards where for every single system we have, you can now go to this dashboard and you can see like all of the relevant bits of information, like who owns it, where's the code, and things like that. So this is our image processing cluster that sits behind our CDN, and you can kind of see where's the public endpoints and all the links to like a useful Splunk log query starting point for looking at the logs. And all this other relevant information. So just the connecting all these things together was immediately already giving us value of being able to see all this information in one place. So then the second question, like I said, was figuring out what's the right amount of investment to be making. So what we ended up doing here was we divided our systems into tiers. So this is just like buckets of importance, essentially. This is just a very simple model. I know other companies sometimes have more elaborate sort of structures around this, but we defined these 4 tiers. And we intentionally said, the very lowest tier, we really want to enable people to move fast and experiment with things that aren't, customer facing. So if it's a very bottom tier of service, all we really care about is, does it have an owner? Does it resolve security bugs? And if it goes down, does somebody eventually bring it back up? Like, that's it. So we try to keep the bar really, really low. Then the next level up is sort of systems that are doing something useful, but it's not like the end of the world if it goes down in the night. So this one, there has to be more than one owner, so we don't have a bus factor problem. There has to be all the infrastructure in place so that team can work on it. So it needs to have development automation, deployment automation, and CI in place. And then it has to have uptime monitoring, so you at least know that it's down. It doesn't mean you'll page, but you at least know how often it's up or down. Then going up to the next level, so these are fairly important systems, but not the most critical ones. At this tier, we are concerned about things like having an on-call rotation, so that when it does go down, you have the alerting in place and you have the team in place to be able to respond to that. Also, we have a lot of more focus on instrumenting the system we use a lot of stats-D metrics that we output from this level of service so that we can get a real-time view of how it's doing. And there has to be some kind of load testing that's done on it, and it has to be able to do deployments without downtime, essentially rolling deploys. And then at the very top tier, we have like our most business-critical systems, and at that level, we're concerned about things like having a very clearly defined SLO that they meet, making use of resiliency patterns, so they need to be using, whenever they're calling out to a third-party service, they need to be using circuit breakers and bulkheads and all that to make sure that they're resilient to that third-party system. One of the biggest ones is they need to be tolerant to a single data center outage. So they need to either be able to gracefully have a data center failover, or they need to be running in multiple data centers concurrently and be able to handle one entire data center going down. So that just gives you a feel for the kinds of things we decided need to be in place for these different kinds of systems. So from that, we have all this information about the system, and we have the systems categorized into these 4 different tiers. From there, we can build a scorecard view. So this is, if any of you were in the LinkedIn talk, we, turns out, built exactly the same thing as them. So we were able to produce these personalized scorecards for an individual or a team or an executive, where they can see all the systems that they own or are involved with, and see, first of all, this quality score, and then we've picked out like the most important pieces of infrastructure that need to be in place, and you can see it all in one place where the problems are. And this actually turns out, this very top row, I realized afterwards, is a staging server. So it's actually, the fact that it's missing a few things isn't that bad. But this is, yeah, so you can kind of see a view of these different systems and how well they're doing. So our third goal, so automation. So this is where it became really fun. So now that we're connecting out to all these systems, we know what's wrong, we know what we need to do. Now we can start building automation to help fix it. So the first thing we do, it's fairly simple, is we have this system is able to automatically open GitHub issues against services that are failing a check. So this is one that actually happened last week, where we moved a system into another cluster and the public endpoint changed, and this alert said you don't have uptime monitoring anymore because Pingdom's monitoring the old URL, which is just a redirect, and nothing's monitoring the new one. So it opened this issue, and then when it was resolved through some other means, our application automatically closed the issue. So we open defects, and even better, automatically close them when they're no longer applicable. The next thing we did with it was being able to fight the battle against email robots. So, email is a terrible, terrible way of alerting, right? But we have a lot of third-party systems, I'm looking at you, Redis Labs, that use email to tell us when things are broken. And that's just one example. There's a bunch of different systems. So what we do is we have our service database intercept these emails, and then it categorizes them and decides, like, is this actionable or not? If it's not actionable, out the window, and if it is actionable, it routes it to the appropriate team that owns it right now, so they can respond to it. So another thing we started doing with this system is automatic infrastructure setup. So this example is there's a system, an application that is missing an uptime monitor, and we know how to call Pingdom APIs. We could set that up for you. So you just click fix this, and it'll go in, call out to the third-party system, hook up the Pingdom API, and then we've got uptime monitoring for that server. And we've got a few different systems like that. We also do automation of setup for PagerDuty schedules for a system, and also wiring PagerDuty up to different monitoring we can do automatically for you. Not for you, for people who work at Shopify, sorry. So we definitely like to push more on this on the automation side. So this is actually the contribution graph of our Shopify services bot, and it's like on track to beat me in amount of productivity in a year. So we'd really like to push on this and start to do things like automatic updates. So, for example, very routine software updates. No reason why a bot couldn't open a PR for you at least, right, and have it run through CI and be able to get you going on that. And also, there's a number of different bits of configuration information. I know it's an anti-pattern, but sometimes we have configuration information in a repo that needs to be changed across a whole fleet of systems. We can use this tool to automatically open pull requests against a whole bunch of systems to make a particular change. So that's something that we've just started to do, but we think will be really valuable in the future, where we can sort of tackle whole classes of problems and build automation to solve them rather than doing it in a one-off way. So some of the takeaways from us for this. So the first one about ownership. This was a really interesting conversation in the company. There was a lot of resistance to the idea of like defining ownership, because we really valued this model of anyone being able to jump in and fix things that are broken. So we did this very deliberately and carefully. And I definitely encourage you to look at like how is ownership defined in your company. And if you think about that slider, maybe you're too far to the left or to the right, and there's a sort of a happy spot you can find there where you defined what ownership looks like, what that means, and who is the owner of your different systems. We found that to be a very valuable result of this project. And then the second one is, thinking about it, infrastructure investment in terms of trade-offs rather than in terms of like we just need to be always doing more. So we had never actually stepped back and said this other system, like we had implicitly done it, right? Like the most important things obviously had all the best automation in place and the best infrastructure in place, but we'd never like it was never deliberately done that way. It just sort of ended up that way, right? So making that decision that, oh, this thing is actually, if it goes down in the night, it doesn't matter because it just produces a report once a day, and if it's up once a day for an hour, we're good. So being able to define that and be intentional about what are your goals for your system, and make sure that you don't spend too much time on because you could easily just throw buckets of money at this and always be trying to increase the resiliency of all your systems, and maybe the value for that isn't there, right? So being intentional about that was really valuable for us. And the third one, which I think is fairly awesome, fairly obvious for anyone at an SRE conference, is focusing on automation. So in our case, it was the insight that we're actually spinning up new systems at least once a week. So all the manual things that we do to set up new systems is not going to scale. And we really got to focus on automation for that, so we can make sure that we can get ahead of that growth curve, and the next 300 systems that get spun up, we'll be able to do it in a much more sustainable way. So I think I blew through it. About good? Okay. So I guess I have time for questions now. So if you have questions, you can make your way up to the microphone in the middle. If you don't, or if you don't think of it until afterwards, Shopify has a booth out in the exhibit hall, and I'm going to be there after the talk for the next couple of hours, I guess. So you're more than welcome to come and talk to me there if you have more questions. And also, we have quite a few other members of the Shopify production engineering team here who have lots of other interesting things they can tell you about. We're not selling anything, but come by the booth and talk to us, and we're happy to chat more. So any questions for now, or no? Okay, thank you very much.